So I will speak about a teeny portion of what I do at my company, which is called Cluepons. I will present object-oriented pattern, accumulators. I don't know if any of you are familiar with accumulators. Okay, thank you. So for Cluepons, we deal with clinical data. So when a pharmaceutical company wants to put a drug on the market, they do what is called a clinical trial. So they ask doctors and hospitals all over the world to follow a certain protocol and take measurement at different points of time on patients. So blood tests, different kind of measurement. Everything is collected into forms, and in the end, we have medical records, which are simple data set in a database. So, and we do some statistical tests on those data sets to see if there is any errors in them. So, for example, did the doctor follow correctly the procedure? All the measurement has been done with the correct units. So we can pinpoint some kind of errors, but also we can pinpoint some problems. For example, we see that a certain hospital, all the data are somehow off with respect to the rest of the data, so there might be a problem. So the pharmaceutical company will send someone, a monitor, to see what's wrong with that hospital. And all of that is because putting a new drug on the market is very expensive. For example, for the moment, it's $1.5 billion per drug. So you want to cut it as fast as possible. So there is a scientific core engine, and it's coded in C++. So, of course, we want it to be fast. Don't use any memory. You don't want to have any errors in it. And as I said, the data is organized in dataset, and we want to analyze everything of this. Mostly, to summarize, the statistical tests involve some operations, so aggregation, some average, variance, and so on one or more variable based on some key variables. The key variables are the hospital, the patient, but also the visit, and so on. And sometimes there is some pre-processing, like we want to have the sum per patient, the sum per visit, and so on and so on. And here comes the accumulators, because we want to iterate over all those data and do some operation, but sometimes the iteration is not that simple because we have to add some filtering and everything, so we want to separate these two, so in order to test everything. So I will just show you. For example, to do the sum is very simple. You initialize the sum to 0, and you iterate over the vector, and you add all the elements. And if you want to do the mean, you divide it by the number of elements of that vector. Okay, that's quite easy, but everything is mixed. So with an accumulator, here I use, for example, the boost accumulator. So you set up your accumulator, you inject all the values into that accumulator, and at the end, you have the mean. So you have separated the two. That's great. You can use boost, but boost has as a lot of accumulators do a lot of operation, but sometimes it's not exactly what you want. So, and also sometimes you also want to minimize numerical errors. Boost is not perfect for that, so just simply show you an example with the sample variance. So you have the mathematical formula here, and it's perfect, except it's a two-pass algorithm, because you first have to compute the mean of the value, and then the variance. So you take all the elements, you subtract the mean, you take the square, take the sum, and divide by number of elements. So that's quite okay, but sometimes the number of elements is very high. So, and you cannot, if you use that formula, you cannot see how the variance evolve with the number of elements, so it's not great. There is another mathematical formula where you can compute the variance at any point in time, but that formula is very unstable mathematically. So, for example, if you use float, even with 3 numbers. So 10,000, 10,001, and 10,002. 10,002, this formula, instead of giving you 1, give you minus 10.66666, which is completely wrong. So maybe if you go to double precision, yes. But if you have a large number, even with those 3, result is 0. So completely wrong. So luckily, there is some other formula which has been developed for the simple variance by Welsford. You have this. So you have 2 numbers to compute, which is a bit more memory, use more memory. But then the the formula is very stable, and you can put it as an accumulator. So that's simply the accumulator for the variance. So you have the number of elements as size t, so no problem. So the first order moment, m and s, which is analyzed to 0 first. The operator parenthesis simply add the element. You just check that you are not adding a non-valid value. You increase the number of elements and you compute, and then at the end you can take the average and the variance with calling average and S2, and you obtain the right result. So I would like to thank you for your attention. I guess the previous accumulator is very stable. You don't have the problem of the previous one, and you can always get the value at any point in time. So that's fine. And I just wanted to introduce you the concept of accumulator, because it's very useful, and you can test your code very easily because you separate it completely, the iteration from the operation. So if you have a better accumulator, because it's more precise, it's faster, and everything, just have to change nothing in your code except the type of the accumulator. So yes, thank you for your attention. If you have any question, I'm ready.